Alright, so I am just going to clarify what I know I confused you guys in during recitation, but for number 4, we're just going to talk about this relationship between them and are they isomers or not, because we already drew in the hydrogens. Just remember the carbons and hydrogens. Remember the points are carbons, and each carbon has 4 bonds. Now if we have 2 carbons right here, these have 1, 2, 3, because pi bonds are 2 bonds each, 1 bond each. 1, 2, 3, there must be a hydrogen coming off of here, right? So 4. Now 1, 2, 3, 4, right? So just one thing I really want to point out in case you come across it on like a test or anything is, say instead of just drawing a line right here, which means there's a carbon at the end of it, if we drew a hydrogen, that would mean that this bond, there's a carbon here with 3 hydrogens off of it, but that this carbon is simply bonding to a hydrogen, and that there's not a carbon on the end of it with 3 hydrogens. But if there's a hydrogen like explicitly shown right here, that means there's just a hydrogen there. I just don't want that to show up and you guys think that there's they're just like focusing on one hydrogen. But so between these 2 molecules, the difference lies right here, right? Everything this way is the same. It just looks like this rotated down, or that this could like rotate up. Now I just want to clarify because I totally jacked this up in recitation, but we have oxygen, carbon, 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 carbon. We have a double bond right here and a double bond right here, right? So because these double bonds lock or sticks lock these atoms and bonds into place, you couldn't rotate this whole section. Now, because we're looking at this, you're like, well, we did rotate it. No, we didn't, because this is what we call an isomer, which means it has the same formula, but it's a different compound or a molecule. In order to get it from point 1 to point 2, we would literally have to break bonds and make them. And so if we ever have to do that, that means it's an isomer as long as it still has the same chemical formula. So let's say that instead of having a double bond right here, we only had a single bond. Now then we could rotate that down and it'd look like oxygen, carbon, 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 carbon. And that would be the same thing as this, even though we rotated it, because single bonds, carbon, 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 can rotate like this. We could rotate this up and it'd be carbon, 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 and that's technically the same thing. If we just say turn the molecule on its side, it's going to look exactly the same. So with this, because they're oriented differently due to these double bonds, these are going to be different molecules. But I want to focus on like right here and right here. Let's do it on this one just because it's easier to draw, so my drawings won't look as messy. Let's say we have the same molecule, oxygen, right? Let's say at this point, we're at this point right here. We say we want to rotate this whole half down. Now what that would look like is we would go down, and then it would go this way. So we just made this point right here. It would look like that, okay?